Hello everyone, this is Charu. I have started this video lecture series to solve all the practical problems related to statistics. In this lecture, we will start solving the practical exercise questions of binomial distribution. So, in this video series, we will try to solve all the practical questions, all the practical problems related to binomial distribution. So as you all know that we are starting this series to solve the practical problems, and while solving these practical problems, I have already assumed this, that you all know what is binomial distribution, what are its assumptions, and what are those conditions where binomial distribution is applicable. But still, I will try to explain some points about binomial distribution in a very brief method. Binomial distribution. Binomial distribution was discovered by a Swiss mathematician James Bernoulli, and it is used in such situations where an experiment results in two possibilities, success and failure. As I already stated that I'm here assuming that you all know what is the meaning of binomial distribution. So that is why in brief I'm trying to explain that binomial distribution, it was discovered by a Swiss mathematician James Bernoulli, and this distribution, or this is applicable only on those situations where an experiment results in two possibilities, success and failure. In those experiments we will try, or we will use binomial distribution. Now moving to its assumptions. Before using binomial distribution, we must know about the basic assumptions that are used while applying binomial distribution. First, finite number of trials. Under binomial distribution, we have to take the assumption that the number of trials or the number of experiments will be limited or finite. And the second assumption is mutually exclusive outcomes. Whatever experiment you are doing, the outcomes of that experiment will be mutually exclusive. Now, what is mutually exclusive? Mutually exclusive means those events which cannot happen simultaneously in a single trial. Or mutually exclusive outcomes or mutually exclusive events are those where the possibility of happening on happening of an event eliminates or reduces the possibility of happening of other event. Those events are called mutually exclusive events. So here outcomes of the experiment or trial will be mutually exclusive. Third assumption, it is saying that the probability of success in each trial is constant. We have to assume that the probability of success, whatever we are taking as our success, the probability of success will remain constant in each trial. Despite how many trials or how many experiments you are conducting, that doesn't matter. The only thing we have to assume here is the probability of success will remain constant. Next assumption is trials are independent. All the trials, all the experiments you are doing, they are independent of each other. First trial, first experiment will not affect the outcome of second experiment. Outcomes of second experiment will not affect the outcome of third experiment. It clearly states that all the trials, all the experiments are independent of each other. Outcome of a single trial will not affect the outcome of any other trial. All the events are independent. So this is the base for binomial distribution. Binomial distribution, it was discovered by Swiss mathematician James Bernoulli. It is used on those situations where an experiment results in two possibilities, success and failure. And under binomial distribution, we have to use certain assumptions before applying it. Under these assumptions, first one is finite number of trials. All the number of trials or experiments will be limited or counted or finite. And the mutual exclusive outcomes, all the outcomes of experiments will be mutually exclusive. That clearly states that they can't happen simultaneously in a single trial. And the probability of success, which is denoted by P, that will remain constant in each single trial, and all the trials, all the experiments are independent of each other. One trial cannot affect the outcome of other trial. These are the basic assumptions of binomial distribution. I hope you all must know that before starting the practical problems of binomial distribution. So now moving towards solving our exercise number 1 of binomial distribution. This is our exercise number 1 of binomial distribution. In this exercise, we have total 14 questions, and we will try to solve all these questions one by one, starting from its question number 1. Before going ahead towards our practical questions, firstly we need to know the formula of binomial distribution. As I have already stated that I am assuming you all know all the details of binomial distribution. We are here trying to solve the practical portion only. So before moving ahead, I will try to just read its formula. And the formula of binomial distribution is probability of x success rate is equals to n c x into में into or multiply q की power n minus x into में p की power x. So this is the formula for binomial distribution, and this is the only formula for solving all the practical questions related to binomial distribution. So this is the only formula under binomial distribution which we have to learn before solving our practical exercise questions. So formula, I'm repeating it again. Formula is probability of x success rate is equals to n. N stands for number of trials or number of experiments, which n number of trials. C stands for combination, and x, this x means a success rate. If they are asking for probability of head, how many times do we need the head? This must be denoted by this x, which we call as success rate. Then into q, q की power n minus x, and this q stands for probability of failure, or we can say it as a probability of non-happening of an event, and its raised power is n minus x. Again, n is total number of trials minus x is success rate into में p, and its power is x. P stands for probability of happening of an event, or we can call it as probability of success. So q stands for probability of failure, this small p stands for probability of success, and its power is x. Again, this x means success rate. So this is the formula for calculating the probability of x success rate. And before moving forward, we need to remember this important statement. This statement is from the chapter basic probability or simple probability, which states that probability of happening of an event denoted by this small p plus probability of non-happening of an event denoted by this small q is equals to 1. It means probability of happening of an event plus probability of non-happening of an event. If we sum together these, the total probability will always be equals to 1. And this is the formula of solving combination. N C x, and the formula is n factorial upon में x factorial bracket n minus x factorial. This is the formula for solving combination of n C x. So this is the formula portion for solving binomial distribution. I hope you all get this Now moving towards our practical question. Starting question number 1. In this, a fair coin is tossed 6 times. A fair coin is tossed 6 times. What is the probability of obtaining? We have to find the probability of getting 4 or more heads. That's it. This is the entire statement of the question, and in this they are saying that we have a fair coin and this fair coin is tossed for 6 times, and out of the 6 throws we have to find the probability of getting 4 or more heads. So out of these details, firstly we need to identify all the items related to the formula of binomial distribution. First, n. N means total number of trials or total number of experiments, and here n will become 6 because we have tossed this coin 6 times. So n will become 6. Next, x. X stands for success rate. Now here success rate will become 4 or more heads. They are asking for the probability of getting heads. So head will be denoted by the probability of success, which is denoted by small p, and small p is probability of head in a single trial. And in a single trial we clearly know that probability of getting a head in a single toss is 1 by 2. So probability of getting ahead in a single trial is 1 by 2, and success rate is 4 or more, and n is 6. And now we need one more thing, which is q. Q stands for probability of failure, and probability of failure in a single trial, which means probability of getting a tail, which is also half or 1 by 2. After identifying all the items required for the formula, now our next step is to substitute all the values into the formula. And what is the formula for binomial distribution? Formula is probability of x success rate is equals to ncx q की power n minus x into में p and its power x. This is the formula for binomial distribution. Now substituting all those values into the formula. N was 6, x was 4 or more. Then Q stands for failure, and the probability of failure in a single trial was 1 by 2. And P stands for probability of success in a single trial, that was also 1 by 2, and X will decide X according to this information. So they are asking for probability of 4 or more heads. They are asking for 4 or more heads. 4 or more. So it clearly means that out of 6 tosses there can be 4 heads, there can be 5 heads, or there can be 6 heads. It means out of total 6 throws, they are asking for 4 or more. 4 or more stands for it could be 4 heads, it could be 5 heads, or it could be 6 heads. And here all these events are mutually exclusive. So, and we all remember this rule from the chapter probability, that in case of mutually exclusive events we have to use addition theorem. So for calculating the probability of 4 or more heads, we need to calculate probability of 4 heads plus probability of 5 heads plus probability of 6 heads, because there is a condition of either or probability of 4 or probability of 5 or probability of 6, and in this case of either or when the events are mutually exclusive, we have to apply the addition theorem. So that's why we have applied here addition theorem, probability of 4 success rate, or you can call it probability of 4 heads plus probability of 5 heads plus probability of 6 heads. Then you will get the probability of 4 or more heads out of total 6 trials. So firstly we need to calculate the probability of 4 success rates separately. Then we will move forward towards calculating the probability of 5 success rates separately. Then moving towards 6, all these probabilities of each success rate will be calculated separately. Firstly, we will do all these calculation work for 4 success rate, then for 5 success rate, and then for 6 success rate. After calculating individual probabilities of 4, 5 and 6, at the end we need to add the probabilities of all those success rate together. So now calculating the required probability. This is the probability of 4 success rate, this is probability of 5 success rate, and this is probability of 6 success rate, which we have calculated earlier. Now adding all these probabilities all together, this is the final value of, or this is the total probability of getting 4 or more hits. So this is the final solution for this practical question number 1. So this is our question number 2. In this they are stating that a die is thrown 4 times. A die is thrown 4 times and getting a number greater than 2 is considered as a success. Find the probability of. Under first point they have questioned for getting exactly 1 success, and under second point they are asking for less than 3 success, and under third point they are asking for more than 3 successes. This is our question number 2. And after reading the entire statement of this question, firstly we will try to separate or identify all the items related to our formula of binomial distribution. Firstly they are saying that the die is thrown 4 times, so n will become 4. Next they are saying that getting a number greater than 2 is considered a success. This question is related with a die experiment. We have thrown a dice and this die was thrown for 4 times, and we know that in a single trial, in a single throw of a dice, there are 6 possible outcomes, and on that dice there are numbers, there are dots pointed on that dice, and those numbers are starting from 1 to 6. We have 1, 2, 3, 4, 5, 6 these numbers on a dice, and they are asking for a number which is greater than 2 on a dice. And we know that out of 1 to 6 numbers we have total 4 numbers which are greater than 4, and those greater numbers will be considered as a success. It means probability of getting a number greater than 2, and these numbers are 3, 4, 5, 6. So the total possible cases will become 4 by 6. So the probability of getting a number which is greater than 2 is 4 by 6. Now P is 4 by 6 and Q will become 2 by 6. Or you can find out the value of Q by the statement P plus Q is equals to 1. When we have a value of either P or Q, we can calculate the probability of unknown variable or unknown item by deducting the value of known item from 1. So out of that statement, you can also calculate this value of Q. Q is equals to 1 minus P. You will get the value of Q or probability of failure, which will become 2 by 6. Now they are asking for getting exactly one success. So here success rate will become 1. And the second point, they are asking for less than 3. We have to find the less than 3 successes. And under third point, they have questioned more than 3 successes. Here we have to find the probability or the possibility of getting more than 3 successes out of total 4 trials. So this is the calculation of getting exactly one success. You can calculate it by substituting all the available values in your formula, and here success rate will be treated as 1 because they are asking for exactly one success. So x will be 1. Substituting all these value into the formula, you will get the probability, and the final value will become 0.0988. This is the value, or this is the probability of getting exactly one success. And here under second point, they were asking for less than 3 successes. Now less than 3, it means we have to use all those values which are lesser than 3 because they are asking for less than 3 successes. So less than 3 means we need to find the probability of 0 success, we need to find the probability of 1 success, and we need to find the probability of 2 success because they are asking for lesser than 3. In case of less than 3, we will take 0, 1 and 2. We will calculate probability of each success rate separately and applying addition theorem to sum up all those probabilities and calculating the probabilities of less than 3 successes. So this is the entire calculation for 0 success rate, then for 1 success rate, and then for 2 success rate.